Most people think software engineering means sitting at a laptop and typing code. They imagine a person staring at a screen, writing lines of syntax, and that's the whole job. If that were true, then copying code from the internet would make someone a software engineer. But real software engineering is not about how fast you type or how many lines of code you write. Writing code is only a small part of the job. Software engineering is about designing systems that continue working months, years, and even decades later. Systems that still function while requirements change, while users grow, while bugs appear, while hardware fails, while teams change. To understand why so many people misunderstand this, you have to look at how most of us learn programming. Most learning paths start with syntax, variables, loops, functions. You type something, you run it, it prints output, and that feels like progress. That part is important. You can't avoid learning syntax. But syntax is like learning how to hold a hammer. Knowing how to hold a hammer does not mean you know how to design a house. It does not mean you understand foundations. It does not mean you understand load-bearing walls. It does not mean you know how plumbing and electricity fit together. Syntax teaches you how to use tools. Software engineering teaches you how to design structures. And this word, engineering, matters. Engineering, in any field, is about designing solutions under constraints. You never have infinite time. You never have infinite money. You never have perfect hardware. People make mistakes. Requirements change. Unexpected problems appear. Engineering is the practice of making something work anyway. Software engineering applies this mindset to software systems, not to single files, not to isolated functions, but to systems. Real software is not one file. Real software is a collection of interacting parts. There is usually some kind of interface that users interact with. There is usually a back end that processes requests. There is usually a database that stores data. There are APIs that allow components to talk to each other. There may be background workers running jobs. There may be external services involved. Software engineering is the process of deciding how these pieces fit together. Which parts talk to which? What data flows between them? Where responsibilities live? What happens when something fails? When an application appears to work smoothly, you are only seeing the surface. Underneath that surface are many invisible decisions. Where does data live? How is it structured? What happens if the database goes down? What happens if a request times out? What happens if two users try to modify the same data at the same time? How do we deploy a new version without breaking existing users? How do we detect when something goes wrong? These are not typing problems. These are design problems. To make this more concrete, imagine building a simple to-do app. At a beginner level, you might think, I just need to write code that adds tasks to a list and displays them. But a software engineer starts asking different questions. Where are those tasks stored? In memory? In a database? On a server? What happens if the server crashes? Can users access their tasks from multiple devices? How do we keep data in sync? What happens if we change the data format later? How do we update the app without losing anyone's data? Writing the code that displays a to-do list might be 30% of the work. The other 70% is thinking through these questions. This is why professional software engineers spend much of their time not typing code. They read existing code. They review other people's changes. They discuss designs. They draw diagrams. They debug problems. They write tests. They write documentation. Many days, the amount of new code written is small, but the amount of thinking is large. Because the real challenge is not producing code. The real challenge is producing systems that are understandable, maintainable, and reliable. Another important idea is that tools change. Programming languages change. Frameworks rise and fall. Libraries become popular and then disappear. But engineering thinking survives all of that. If you know how to break down a problem, if you know how to reason about trade-offs, if you know how to design simple systems, if you know how to debug effectively, if you know how to communicate technical ideas, you can adapt to new tools. If all you know is a specific framework, you are fragile. So when people ask, how do I become a software engineer? The deeper answer is not learn this language or learn that framework. The deeper answer is Learn how software works. Learn how systems are structured. Learn how to think in terms of components and interactions. Learn how to reason about failures.